All right, friends, I hope that you had a good break and that you are enthusiastic for the upcoming hour of sessions. We have two more presentations today that will conclude the knowledge sharing part. And our next speaker, a friend of mine, Karlo Knezevic. He's a friend, but Knezevic. Head of AI at Sofascore, who will take us behind the scenes of their cutting-edge analytics pipeline. From tools like Firebase and BigQuery to scaling strategies, Karlo will show us how real-time analytics power incredible user experiences. Karlo, please help me welcome Karlo with a big round of applause.
Welcome, everyone. I'm really happy to be here. And I'm happy to share with you how we at Sofascore handle the big data and how we process big data in real time. And how we, by doing that, support our company to be data-driven. So this is a brief contents of this lecture, something short on Sofascore, then Sofascore data infrastructure, real-time data processing or core of real-time data processing, and just briefly some use cases in our company, and future directions and conclusions. So something about me. I'm a husband, father. I'm 35 years old, coming from capital of Croatia. My alma mater is Faculty of Electrical Engineering and Computing, University of Zagreb. I hold PhD in machine learning and evolutionary computation, applying to symmetric cryptography. And currently, I'm honored to be head of AI at Sofascore. This AI means two things in our company. AI means artificial intelligence and analytics and information. Do you like sports? If you do, I believe that you probably heard of us. If you don't, I believe that your next favorite application is going to be Sofascore. So what is Sofascore? Sofascore is the best sports platform on the world, period. We support 25 sports, and each year we are trying to do best and cover more sports. From football to bandy, from professionals to amateurs, and our users simply love us. Currently, we have 28 million unique active users per month. And all this story started in Croatia. So, data in Sofascore. Speaking on data in Sofascore, we divide data into streams. The first one is sports data, and the second one is users' actions data. So, speaking on sports data in Sofascore, the sports data supports all core features of our product, like statistical player ratings, team of the week, standings, match details, etc., etc. People often ask us, how do we get this data? Well, we buy data from official sports feed providers. We have our own program, Sofascore Editor, which supports sport events, tournaments, leagues that are not covered by feed providers. Also, we have crowdsourcing program where basically our users, fans, can participate in suggesting some changes in score or incidents during the sport match. And of course, we scrape web. The other stream are user actions. So basically, every time our user uses the product, one touches the screen or make a slide, swipe, scroll, we record the event, the occurrence of the event of touching something on the screen, and all those events we gather in the user's action database. Also, we hold a record called clickstream, so that's a detailed log of all users' interactions. And currently in our product, we have over 200 distinct user interactions or actions. And those events are, for example, follow player, open league, open player, app remove, add view, and etc. So in a picture, how all this looks like. So again, sports data, then our product on user platforms. And all sports data is stored in PostgreSQL. Currently, that database is approximately half terabyte large. And on the other hand, all those events created by our users, we store in ClickHouse DVH. Currently, we have approximately 2 petabytes of users' actions in this ClickHouse DVH. So just observing or seeing this amount of data, we can clearly say that in Sofascore, we do with big data. And by Oxford Dictionary, big data is extremely large data set that may be analyzed computationally to reveal patterns, trends, and associations, especially relating to human behavior and interactions. And all these actions, all these things we do at Sofascore. So how much data we are talking about, and where are some peaks? So just stated differently, this 1.5 or 2 petabytes of users' actions data is approximately 1 to 1.5 trillion rows in database. Also, this number, 700 gigabytes, yesterday I asked my data engineer, it's deprecated. Currently, we gather about 1 terabyte of data daily. On this graph, you can see some peaks. Those peaks occur during the weekends, because of course, during the weekends, we have the most amount of sport matches. So why is real-time processing important for us? So here is one map of all some buzzwords. But for us in Sofascore, those words are not just buzzwords. So for example, for us, real-time is extremely important to make user experience better or to optimize operational excellence or make business intelligence better. Generally speaking, on user experience, because of the high amount of sports events, we try to be as much as personalized as possible, because we want to offer each user events or content for him. So let's dive into Sofascore data infrastructure. This is something we started with. So this is the legacy pipeline with some issues, and I will explain what those issues are. So here we have all devices where we are present, and we used Firebase SDK for recording events that user generate and send it to the Firebase database. Then we exported this data to BigQuery. Then we export daily that data to cloud storage. And then the next step was to import all that data to the ClickHouse DVH, which is run on our on-prem server in Zagreb. So why are we doing that? So why don't we just simply use BigQuery? Because we want to make our operational costs as low as possible. And on the other hand, the cost of BigQuery has several variables, like amount of queries or data transferred from Google platform to your office. Because companies growing rapidly, we wanted to control those expenses. So that's the reason why we export all the data to ClickHouse. So where are the issues? The first issue is data duplication or duplicates. And in all that pipeline, we needed to handle that issue. The other two issues were data delay and data loss. So first of all, data delay. Where is the problem? There is delay up to 24 hours from Firebase to BigQuery. So basically, if you have setting like that, you can be real time. And on the other hand, we ran only once our importer from BigQuery to ClickHouse. So basically, we lost more than 24 hours to basically get all daily generated events to our DVH. Data duplication. So the next issue is that a lot of our users are from South America and Africa. And I believe that their network connectivity is not so good as in Europe, for example. And there is in documentation that data duplication in BigQuery primarily is due to client-side network issues. So if network has some problems, then you can have duplicated or deleted missed data. And data loss. The problem is that when you export data from Firebase to BigQuery, that export is not in one batch, but in several batches. We call it waves. In first batch, you get like 98% of your daily generated data. And in other batches are those two imported percent of daily generated data. But in those other batches are mostly duplicated data from the first batch. So for simplicity, we decided in company not to just import the first wave, the first batch of data. And we were thinking how to fix those issues. So the fix was for us to introduce NATS. So what is NATS? NATS is basically PubSub server. We decided to connect all our users or all devices, so I speak on mobile phones and web, to the server. And basically, when user interacts with a device, in the real time, you get the payload or the message, the event in the NATS server. Then, in our Sofascore K8s cluster, we have NATS importer that's also client subscribed to NATS, which basically consumes or reads those messages and imports those messages to ClickHouse. So that was, one would say that was just one simple and quick fix, but we were thinking on other technologies. So in the next slides, I would like to refer to two most important things in this real-time data pipeline. and these are NOTs and ClickHouse. So NOTs, as I said, is open source messaging platform. It is written in Go, firstly in Rust, then written to Go. And, well, that NOTs is abbreviation of Neural Autonomic Transport System. On the other hand, ClickHouse is DVH. This name ClickHouse comes from Clickstream Data Warehouse. It's developed by Yandex. I think the local people are familiar with this name. And it's open source columnar database. I believe you already heard of ClickHouse, right? Yeah. The fact that it's columnar, it's the big thing, and I think at its core, that's the main thing why this ClickHouse is great for analytics. ClickHouse can handle billions of rows with minimal hardware. So, NOTs key concepts. NOTs is essentially pretty similar to Apache Kafka. So all those concepts like subjects, model, messages, distribution, interaction, security are already present in Kafka. And this image, publish, subscribe, isn't something new. But there could be another question. Why NOTs? Why we decided to introduce NOTs in our pipeline? Well, here you can see all the characteristics of NOTs. But on the right side, you can see technologies we were thinking about. So, except of Apache Kafka, we were thinking of using RabbitMQ, Redis streams, but also the cloud platforms like AWS SNS, Google Cloud PubSub. And to be honest, Apache Kafka is high performer. It is well-known tool. On the other hand, NATS is simple, but extremely efficient, extremely fast. Also, there is a paper from 2023, total cost of ownership comparison, and the core of this paper is comparison between Kafka and NOTs, where basically having Kafka in production is several times more expensive than having NOTs. And the main conclusion of this paper was that NOTs outperforms Kafka with lower infrastructure and operational costs, requiring significantly less time and effort while maintaining superior performance primarily due to CPU and network I/O efficiency compared to Kafka. So how do we use NOTs, or how do we consume NOTs queue? So you have client that publish event to our NOTs stream. Then you have the consumer that consumes that streamed message, parse message, and checks if that message is valid. What does it mean if it's valid? So now, the only, let's say, crucial thing why a message wouldn't be valid is developer. So there could be some bug, and that's now the most often reason why some message has some flaws. In the case of some error, that error is logged and immediately transferred to development department. On the other hand, we insert this event to ClickHouse. So NOTs numbers in Sofascore. This 2.5 billion messages per day, that's not some peak. That's the current, so that's not the limit, but that's the current peak we had in last month. So we can handle that amount of messages. That means that we handle approximately 1.7 million messages per minute, or we can process approximately 100,000 messages in 2.5 seconds. What does it mean? It means that if you are in any part of the world and if you touch the screen in our product, in less than 5 seconds, we have that event in our DVH in Zagreb. And that's great. On the right side, you can see some hyperparameters, like batch size, epoch size, or the number of machines we use in our data center. And of course, we use Jetstream. Jetstream is just extension of NATS core with persistent messaging and streaming capabilities. On the other hand, ClickHouse, why it's so fast? There was a lecture before this coffee break. And ClickHouse has everything that the presenter spoke on that lecture. So concurrent architecture, vectorized query processing, etc., etc. ClickHouse is extremely fast. There is also one research paper, and also on Reddit, you can find some topics or discussions, whether to use ClickHouse or Snowflake, for example, where basically a lot of people say that even ClickHouse is faster, and with lower cost, you can get the better performance than Snowflake. So here's some numbers in ClickHouse today. As I said, approximately 2 petabytes, 1.5 trillion rows, a terabyte arriving daily. And where is the magic? How we handle all this data in our team? Because in our team, you have machine learning engineers, you have data analytics, and we daily get questions: how many, how much, when, where, why, etc. So how to handle all this 2 petabytes of data? Well, we have in-house built aggregator service. That's a service that basically crumbles all data gathered from NATS and basically creates the aggregation tables that are used by our engineers or analysts. And that reduces search size by up to 2,000 times. So what are some use cases in Sofascore? Where is that real-time important for us? So first, as I mentioned earlier, data analytics. We need to answer to the stakeholders in company very fast to their questions. Like, in the period of last 6 months, tell me how much money did we earn on some market, or why was, I don't know, some peak somewhere. So data analytics need to resolve those questions in a day, maximum 2 days. Then content personalization. If you want to be state-of-the-art and if you want to have strongly personalized content, you can't wait. So you need to act immediately. So when user does something, you need to change the behavior of your product and to deliver your user the content he or she wants to see. User acquisition, that's extremely powerful and optimized in Sofascore. For example, when we do acquisition, of course, we do some marketing, and we do not show the Sofascore ad to anyone, but only to those users who have capability to become our long-term users. So basically, we do some predictions and classifications and models to predict to whom to serve the Sofascore ad, and of course, monetization. So this is just one quick slide on content personalization and what do we do. So Sofascore drifted to the social sphere where we want to give user the power and possibility to create its own content in application, like to comment something or to be more involved in sports content, like sharing posts, sharing images, create video content, etc. So here we have the real-time user interactions. Then we have feature processing, where we basically create the interest vector. Then we have a huge ML pipeline, where we create user embeddings, also the post embeddings, and basically in multi-dimensional space, we try to find those posts which embeddings are the closest to the user embeddings. And of course, we have the performance monitoring, and finally, the feed generation in our application. Again, without of real time, we couldn't have all this pipeline, all this process. That's extremely important for us. How this content personalization looks like, something like this. So you have one tab in our application, and there you can see the posts only for you. So generally, real-time data profits by turning insights into personalized experiences, driving loyalty and success. And finally, some future directions. How or what are we doing right now? So firstly, we're thinking constantly about scaling, because the user numbers are constantly going up and up. And we especially need to be prepared for peak traffic. Just to give you some number, in peak we can have up to 10 million users, and we need to be able to handle that amount of users. Also ensuring system reliability and uptime. And of course, expanding data sources and pipeline optimization. 3 key takeaways I'd like to emphasize at the end of this presentation is that real-time data is crucial for user engagement, especially if you want to have the personalized content. Next, scalable and reliable infrastructure is the backbone, especially in our case, where in the peak you can have a lot of users and you cannot allow yourself to be broken then. And finally, continuous optimization is needed to stay competitive, but this last sentence you can apply to any area of your life. Thank you.
All right. Thank you very much, Karlo. Do we have questions? There will be some.
Hello, and thank you for the presentation. My area of interest is about the NUTS part with the telemetry from the users. Do you have any security, like authentication or anything else when users connect to your telemetry servers? And is that a performance bottleneck? How many of those servers do you have for the 10 million users you said you have at peak?
Mm-hmm. Yes. Currently, we have 6 servers, but they're horizontally scalable, so we can easily, and everything is run in cloud, so we can easily increase that number of machines, okay? About security, yes, we have the security layer with certificates, so something like SSL. So basically, if someone wants to consume or to use our NAT server, it needs to have our certificate, okay? Yeah.
All right. Do we have more questions? That's it then. Okay. Karlo, thank you very much. Please, let's hear it up for Karlo.
See you.